Hello, this is Chapter 18, Question 35. Men of few words. Researchers claim that women speak significantly more words per day than men. One estimate is that a woman uses 20,000 words per day, while a man uses about 7,000. To investigate such claims, one study used a special device to record the conversations of male and female university students over a 4-day period. From these recordings, the daily word count of the 20 men in the study was determined. Here are the daily word counts. So we have word counts 28,000, the highest here 37,000, the lowest. Looks like we have a very silent man here, only 3,998 words in a day. Um, but it looks like if you look over the overall, most of the men are in the 10,000s, 10 to 20,000 range. So it looks like, yeah, there's some truth to this claim that men speak less than 20,000, but it could just be sampling variation and so forth. So first, part A, examine the data. Is it reasonable to use the T procedures? Assume these men are a simple random sample of all students in the university. So um, we have less than 40. So let's review the conditions real quick here. So first thing for part A, what are the conditions for when you can use the T distribution? Okay, so it's a three-part thing. If your sample size is less than 15, then you should have a unimodal and symmetric sample. All right, well, we don't have to worry about that. Our sample size is more than 15. Um, the next thing, though, if n is between 15 and 40, then your histogram doesn't have to be unimodal and symmetric, um, but we should not have any. So I'll say no strong skews or outliers. So that's the condition if in this situation here n equals 20. So we need to check to see if there's any skews, strong skews or outliers. If there are, then we shouldn't use the t-distribution. So I've got the raw data here. I downloaded it already. Um, we have here, it looks like we have a skew here. We have a lot of the data here in the 10,000 to 20,000 range, but we've got, notice here we got a 37,000, we got a 28,000. Let's just do a quick, let's just check the mean versus the median here. It's a quick way. So let's do median A2 through A21. Okay, so the median's 10,000. Okay, that's not a surprise. Okay, what's the mean? Let's do average of A2 through A21. Okay, so the mean is 12,000. Okay, so almost 13,000 there. So that's about a 2,000 word difference between the mean and median. That's evidence of a skew. Now, is it a moderate skew? Is it a strong skew? If it's a moderate skew, it's okay. We can use the t-distribution. If it's a really strong skew, or if there's outliers, then we shouldn't use the t-distribution here because our sample size is relatively small. So let's make a histogram. Let's copy and paste. There's the let's go to our website here. There's this website here. It's the wesa.net/histo.wasp. It makes histograms for you, so we'll just copy and paste. Here, let's just delete the old data here. All right, let's copy in the new data. Go down, click compute. Let's see what the histogram of this data looks like. Okay. All right, there it is. Here's our histogram. Median around 10,000 like we expected, but there is quite a significant skew here. And in fact, it looks like there might be an outlier. That 37,000 number, awfully big in relation to the rest. Um, so uh, let's investigate that potential outlier there. Let's go back to Excel here. Let's get our quartiles, and let's use the good old 1.5 times interquartile range to determine if we have any outliers. So let's do quartile of A2 to A21, oops, comma 1. Okay, so the first quartile is 7,000. All right, the third quartile, equal sign quartile of A2 to A21, comma 3. That is 13,000. Okay, so that's Q3. One more time, the syntax there. Quartile of the range of data, comma 1. That's first quartile. Quartile A2, A21, comma 3 gives us the third quartile. Okay, let's subtract those two numbers. I could use a calculator, but since I've already come this far with Excel, I might as well finish it off here. So the interquartile range is 6,000. Okay, now already I can see here I've got an outlier. The third quartile is 13,000. 1.5, the interquartile range is going to be about 9,000. 13,000 plus 9,000 is 20 something thousand, but we have a data point here that is 37,000 right here. Okay, so for sure that 37,000 is an outlier. If you want to be technical, you can go ahead and actually compute their 1.5 times the interquartile range is 9,000, and then do the third quartile plus 1.5 times interquartile range. Okay, so there's the upper fence, 22,000, which is just 1.5 times interquartile range higher than the third quartile. So actually the 28,000 and the 37,000, those are both outliers. We have two very, very talkative men in relation to all their peers. All right, so back to the conditions here. When sample size is between 15 and 40, as is the case in this problem, we should not have any strong skews or outliers, but we do. There are two outliers, and I'd have to say that the skew is pretty strong, and a strong skew. Let's take a look at the where's our histogram here? Yeah, there's our histogram. It's pretty skewed. We have the upper tail here is close to 40,000. That's almost 4 times as much as the median down here, or 3 times as much. And so yeah, that's a pretty strong skew. So we have and a strong skew. Okay, so the t-distribution should not be used. T-distribution should not be used. Okay, so what do we do? If we can't use the t-distribution, what do we do? Well, we'd have to use more advanced techniques that you would learn about in a more statistics course, but in an introductory statistics course, we'll just stop right there. We'll say, can't use t-distribution, let's move on to the next problem. Now, part B is, let's go back to the question here. Okay, part B, if your conclusion to part A is yes, well, it's not. Our conclusion's no. So do the data, give it convincing evidence. Okay, let's not even go there. We'll just say, accept the null. We don't know how to analyze this data. Now, you can, if you can arguably, or if you can justify throwing out the outliers, if you can throw out the 37,000 and the 28,000, chalk them up to errors in the measurement or something, then you could use the t-distribution. But in my opinion, it's not valid to throw out those outliers. we just have a couple of talkative guys in our sample. So just accept the null and move on to the next question.